Good morning, students. I hope all of you are fine today. So let's continue with the chapter which we are doing previously, which was Human Eye and Colorful World. Now, students, our next topic is atmospheric refraction. Okay. So what do you mean by this? Students, when light goes from one medium to another medium having different optical densities, then refraction of light rays takes place. Now students, remember one thing, that all the air in the atmosphere is not having the same temperature. Some of the air layers of the atmosphere are cold, whereas some layers of the atmosphere are comparatively hotter. So the cooler air layers of the atmosphere, they behave as optically denser medium for the light rays, whereas the warmer layers of the atmosphere, they behave as optically rarer medium for the light rays. So, in the same atmosphere, you can see there are different layers having different optical densities. Now, when light rays passes through the atmosphere having different optical densities, then refraction of light takes place. So, this refraction of light caused by the Earth's atmosphere, this is termed as atmospheric refraction. Now, let us consider one example, students. Like if we look at objects through the hot air over a fire, then the objects appear to be moving slightly. How it takes place? So the air just above the fire, it becomes hotter. Now this hotter air appears to be optically rarer medium, but the colder air just above the hotter air is optically denser. So when we see the objects by the light coming from them through hot and cold layers having different optical densities, then refraction of light takes place, due to which the objects appears to be moving slightly. Now let us consider some more optical phenomena in nature. Now the first one is the twinkling of stars. Now stars emit their own light, which is called as starlight. Now due to this light, students, the stars shine in the night sky. Now if you look at a star in the sky on a clear night, you will observe that the intensity of the light which is coming from the star, it changes continuously. At one moment, the star appears to be very bright. In the next moment, it becomes very dim. So we can say that the stars twinkle at night, but it is due to atmospheric refraction of light. Now how it takes place, students? When the light which is coming from a star enters the Earth's atmosphere, it undergoes refraction due to different optical densities at different altitudes of the atmosphere. Now the atmosphere is continuously changing, students, and it refracts the light from the stars by different amounts from one moment to the next. Now when the atmosphere refracts more amount of starlight towards us, the stars appears to be bright, and when the atmosphere refracts less starlight, then the star appears to be dim. Now the starlight reaching our eyes increases or decreases continuously due to the effect of atmospheric refraction, students. Okay. Now the next topic is the stars seems to be higher than they actually are. Now why? Due to atmospheric refraction, the stars seems to be higher in the sky than they actually are, as because light from a star is refracted when it leaves the space, that is the vacuum, and enters into the Earth's atmosphere. Now air higher up in the sky is acting optically rarer medium, but that nearer the Earth's surface is denser medium. So as the light from a star comes down, the dense air bends the light more. Now due to this refraction of star's light, the star appears to be at a higher position. Our nearest star, the sun, also seems higher than it actually is, due to which it is the phenomenon of atmospheric refraction, students. Okay, and the next topic is the advanced sunrise and delayed sunset, students. Now sometimes the refraction of the light rays tend to bring into view the objects which are actually below the horizon. Horizon means when the sky and the land appears to meet at a point. Okay, thus we can see the sun about 2 minutes before the actual sunrise and 2 minutes after the actual sunset, due to which of atmospheric refraction. Now how it takes place? Now, we consider the case of sunrise first. The actual sunrise takes place when the sun is just above the horizon, students. But due to the refraction of sunlight caused by the atmosphere, we see the rising sun about 2 minutes before it is actually above the horizon. Now, when the sun is slightly below the horizon, then the sun's light, which is coming from less dense air to more dense air, it refracted downwards as it passes through the atmosphere. Now, because of this atmosphere refraction, students, the sun appears to be raised above the horizon when actually it is slightly below the horizon. So, it is also due to atmosphere refraction that we can see the sun for about 2 minutes even after the sun has set below horizon. Now, we can see the sun 2 minutes before the actual sunrise time and for 2 minutes after the actual sunset time. So, the time from sunrise to sunset is lengthened by about 4 minutes due to atmosphere refraction. So, the sun appears flattened at sunrise and sunset. So, the apparent flattening of the sun's disk at sunrise and sunset is also due to atmospheric refraction, students. Okay, students. So, that's all for today. We will continue with our next class. So, thank you for today.